Okay, so let's talk about pressure. So pressure, by definition, is force acting normally per unit area. So you must have the word normally. So what does it mean by normally? That means it must be perpendicular to your area. For example, if let's say this is my area, I must take the force F, which is perpendicular to the surface. Then I will get the pressure. So that's why you need to have the word acting normally, which most people will forget. So the unit for pressure will be Newton per meter squared or Pascal. Now pressure, is it vector or scalar? It is scalar. For example, water pressure. If you are swimming in the swimming pool and you dive inside the water and you're swimming underwater, do you feel the water pressure acting on you? And do you sense it's only one direction or in all directions squeezing you? All directions squeezing you, right? So because it acts in all directions, therefore it cannot have a specific direction, so it is a scalar quantity. Understand now? So in our syllabus, we are going to talk about pressure in liquids only. Pressure in gases, we will come to it in A2. Okay, they shifted it from your AS to your A2. So you're only going to learn about pressure in liquid. So you also need to know how to derive the formula for pressure in liquid. Now most of you all know the formula is H rho G or rho GH. You do know the formula, but it is compulsory for you to know how to derive it in your syllabus. So how do we derive it? The idea is the pressure in a liquid is due to what? What causes the pressure due to liquid? For example, when you're swimming underwater, you feel this water pressure, but where does it come from? Now, in this theory, we will assume that it is because there's a weight of the liquid acting above you that's pushing down that gives you the water pressure. Example, now let's say this is a water surface. Okay, so this is a water surface. And you're taking a column of water beneath the surface. So this is not a separate object, but this is a column of water beneath the water. You take a section of the water, understand? So the pressure acting at this bottom surface here is because there's the entire weight of the water above pushing down, correct? So the whole weight of the water pushing down on this surface gives you your pressure. But people say, if the weight is downwards, shouldn't the pressure only be downwards? No. So when we say the pressure at this surface is due to the weight of the water above it, it will cause you a water pressure at this point, but in all directions. Because as it pushes down, then all the other liquids start to push back. So you have all the water pressure in all directions. Do you understand that? Okay? So we derive the formula by taking the weight of the object divided by this area. That's how we get the pressure, because weight is a force. So force divided by area is pressure. Do you understand that? So let's start from derivation here. So we say the pressure is equals to the weight of the column of water divided by the area here. So the column of water, the weight is mg, and the m here can be broken down to density times volume, right? And do you also realize that the volume of the liquid here is also the area times height? Can you see this part? Area times height is the volume. So you break down the V to AH, then you substitute inside here. So I just show you from here. If you don't want to straight away get the answer, it will be density times AHG over A. You can cancel, and that's how you get rho Hg or H rho G, or whichever term you like to, whichever form you want to say it. Understand or not? Okay, so this derivation very important, so make sure you know how to derive it. So it's actually quite simple. Just start off by taking the weight of the column of water divided by the area. That's it. Okay, now what does this formula tell us? What is the significance of this formula, which is P equals to rho Hg or H rho G, depending on how you want to write it? What's the significance? It means that the pressure in a liquid is only due to the height of the water, or in other words, is the depth of the water or the depth of the liquid, and the density of the liquid, and the G. Give an example. You look at these these five shapes, 5 containers here, or 5 vessels here, all of different shapes here. Do you realize that they all have the same height? So at the if you want to find the pressure at the bottom at the bottom of each vessel, want to find the pressure at the bottom of each vessel, do you think they'll be the same? Yes, they'll be identical. Even though their shapes are different, even they may be slanted, it doesn't matter. It only depends on the vertical height, which are all the same type of liquid, so density is the same, G is the same, so same pressure. Do you understand? It also means that if you have let's say a vessel which is slanted, okay, let's say this is my vessel, and you fill it with water here. To find the pressure at the bottom here, we must take what? The vertical height. H, understand? Okay, you must always take the vertical height to find the pressure. Okay? Now, do you need to add atmospheric pressure if you want to find the pressure at this point? It depends on how the question is worded. If they say find the pressure at the bottom of the vessel or the bottom of the container, then you must add atmospheric pressure, because atmospheric pressure is actually due to the collision of the air molecules on the surface. So there will be an added effect. So you will have to add the atmospheric pressure. But if you don't want to add atmospheric pressure, or you don't need to add atmospheric pressure, then the question must say, what is the pressure at the base of the vessel due to the column of liquid? Then you don't have to add atmospheric pressure, because they only say due to the column of liquid. Do you understand? Okay?